Hey, and welcome to another live coding. Um, so today in live coding, we're going to do a few different things. All are surrounding this pill defect dataset. So what we're going to do is, well, first of all, look at the dataset as usual. After we looked at the dataset and got an understanding of it, we won't be jumping straight into PerceptiLabs. Instead, we'll be creating the CSV file for it, just to show a little bit of how that looks like for a data set here, which doesn't have any CSV already. Then we'll jump into PerceptiLabs. We'll create the model, try out a few different things as usual. And finally, we'll export the model and use the exported model and see how you can do that. So let's start. Let's get to it. So first thing first, we'll take a look at the dataset. So it should be linked in the description below if you want to follow along. But this is how it looks like. We got it from a normal Kaggle page. You can find a few different folders here. You have defect all, defect sample, and normal. And as the name may suggest, it's a data set to classify defect pills, medical pills, for example. So you can take a quick look at it, and it looks a little bit like this with the different defects. So you can see how they are. They have a mark in them, and we have the normal ones, which are just normal cylindrical ones. So I already went ahead and downloaded this dataset, so you can see it here. I removed the defect sample because we don't really need that. We just need the two classes of defect and normal. And after we've done that, next step is to create a CSV file, which I usually will just show. But let's do as this stream actually is called and do some live coding, or look at code live at least. And this is a little script I usually use to create a CSV file. And there's a bunch of very different ways you can create them, but what this one does is simply just look at the folders and names the classes after different folders. So going through it quickly, we point out whichever folder we are in, or we want to create a CSV file in. We then list all of these folders. We create arrays for images and labels, or lists rather. And then we start looping through all of the different directories and fetch we fetch the file name of the directory just to make sure it is an actual directory and not some other weird thing that I know Mac, for example, oftentimes have a hidden file in there. We then get all the files from within this directory, and we go through the files and we add the files, just the normal file paths or the relative file paths to the train folder rather, into the images list, and we add all the directory names into the labels list. And I don't know why we have a counter. I don't think we need that any longer. But after that, we just create a data frame from it and turn the data frame into CSV using pandas. So if we want to run this, it's not going to look like much, but we can run it, and then we can see that we now have, there we go, have a CSV file in here, and we can open it. Take a look at it as usual, and we can see that we have all the images, so the different defects, pills with the label defect, the same as the folder, and just keep scrolling further down, we'll find the normal pictures as well. So that's a quick and easy way to create a CSV file. We can close that one. Okay. So now that we have that and we have the different images, we can just load the CSV file into PerceptiLabs. So let's jump over to that. And in PerceptiLabs, it's as usual at this point. I got a comment. Instead of checking extension, more reliable method would be if not OS path. Very true. That would be a quicker way of doing it. I may update the code to present that instead. Thanks. Where was I? Right, inside of PerceptiLabs, we just load the dataset, and I already I'm running on a server now, so I already uploaded it. But we select the CSV file as usual. We select input, we select target. We now also are able to select do not use if we want to do that. What this does is if you have a large data set and there are some features or columns you don't need, you can just remove them and they won't create any input or target components. So really handy. Then next and customize. So this is a fairly, as you saw in the images, this is a fairly simple data set, so I doubt we need any large pre-trained model for it. Just a standard convolution would work just fine. And we can just run it like this and see how it performs. Important to note is that we have sigmoid in this convolution, so you see if that works well or if we need to swap over to Relu. Now we can lower the number of epochs a little bit and swap over to cross entropy. See what happens. The images support pre-processing. They do. I can show that real quick after this one, how that would look like or how you would do it. So even with a very simple model, we get really high performance, actually perfect performance. And we can run the test just to see that the testing data also looks fine. And there we go. 100% categorical accuracy, and the confusion matrix looks perfect. So going back to the question from you, Fast Neuron, Fast Neuro even. So if we select here, you'll see these little 3 lines at the very top. If you press on this, you'll get some pre-processing options. So we have a few in here, which are some we got in the most requests on. If you have any more you want in, just throw us a comment in the forum or in this YouTube video, and we can look at adding it. Yeah, we're resizing automatically, so you always have something which works for all your models. You can also customize it. You can do some random flipping, where you get to set a seed if you want. Random cropping. This is very useful in segmentation, for example, if you have huge images and you just want a small piece from both the image and the mask. And random rotation. Some more we'll be adding soon probably is blurring and maybe obscuring, we'll see. But at the very least, blurring should be coming in not too long. Okay, before we export it and build a and run the model outside of PerceptiLabs, we can just real quick for fun's sake see how this would look like with a larger model. sometimes the big oh right, we need to convert it to RGB. That's another pre-processing we'll be looking at adding. So we can run it in RGB as well. Let's see. TensorFlow, grayscale. Usually I have this prepared, but I was not planning on doing this one. Let's see. Inputs equals to TensorFlow grayscale to RGB of the input. There we go. Now we can connect it up to the mobile net. And see how that one runs as well. We're also looking at updating the statistics view a bit. So if anyone has any opinions on some statistics which are or should be really useful, just let us know. We can see if we can add that in as well. So we can see here it looks pretty good. We're doing a few misclassifications. Not any longer. Okay, it becomes perfect a bit earlier than the other one, but it's still a fairly simple data set to train on. We can see that it exists, but it's very, very small. So let's just stop this one. And we don't need to test it. The results will probably be very similar to the other one. So let's jump. I'm running this on our server, and we don't, as I said, and we don't have the ability yet to export out of a server. So I went ahead and prepared, essentially ran this locally when I wasn't streaming, and exported it exactly the same first model we did, the convolution, and exported it into here. Here we go. So under code we have the pills model, and if you export as normal TensorFlow, this is exactly the folder structure you'll get. You'll get a model, whatever you call it. You'll get some assets, which will be empty. You'll get variables, which you don't need to care about much. And then you get the saved model.pb. So with this, we have everything we need to load the model and run it. So if we jump back into the code editor, we have a little run model script here. So just walking through what this one does first before I execute it. We have a mapping, and this is temporary. This will we have a post-processing pipeline in PerceptiLabs. However, that one's not automatically being exported. Only the pre-processing pipeline is at the moment. So I just build this one manually right now, and in a bit this one you'll be able to just load this one as well. Then we have the path to the model, which is exactly the exported model I just showed. We then have a load image function, and all we do here is we just load the image, but we then need to take care, because if you just use peel for loading an image, the format won't be the format which TensorFlow expects, and you'll get some weird error. I don't recall exactly how it looks like, but what you want to do is to convert it into float 32, and you want to run expand dims so that it thinks it has a batch dimension as well. Hey Batman. And if you don't do this, you're just sending in the plain image, which will be, in this case, 500 times 500 times 1, while it's expecting a 1 times 500 times 500 times 1, or actually question mark times 500 times 500 times 1, where the question mark can be anything, in case you want to run a bunch of images through it at the same time. We then load some random images. I just picked the first ones in the folders. So these are training images, which are not ideal to run test on, but just to see how it works. We then use Keras to load the model, and we run the model by doing this. So we just take model and the argument, whatever we want to send into it. So if we run this, it will look like this. There we go. So the first thing you saw is just TensorFlow spinning up, loading my GPU, and then we finally load the model, and this is the prediction. This is the raw output of it. So we get back a dictionary with a key labels which points towards some TensorFlow objects. So the step after that we do is to get the actual prediction is we just convert, well, first of all, we take the content of the key, or the value of the labels key. We then convert it to an array. We run argmax on it, in case it wasn't as binary as this. We'd probably have some values on the other spots in the array as well. And then we just run this through our mapping to convert whatever number we get from the argmax. And the argmax, for those who don't know, it takes the position of the highest integer in the array, or the highest float in the array. And then we just convert it through the mapping. Oh, sorry, my camera is covering. Thank you for pointing that out. Let me move myself real quick. There we go. Hopefully that makes more sense. So this is how the entire dictionary would look like. And as you can see, you have the labels, and you have the TensorFlow objects, and you have the array which we take. And that's how you run a PerceptiLabs model. I'll post both the CSV creator and the run model script in this video when it goes up as well, so you can access it if you want. Usually it takes about 1 week for it to go up, so let me know. Just post in the forum, or reach out to me if you want it any quicker or have any questions about it. But yeah, that's everything I wanted to show today. It's to summarize, we downloaded the dataset from Kaggle, from Pills. We created a CSV file using this CSV creator. Very simple, just checking the different folders and naming the classes after the folders. We then loaded the CSV into PerceptiLabs, built a quick model for it. The recommended model already gave 100% accuracy. We then exported it, which became a standard TensorFlow model with their data structure or folder structure. And we then loaded that TensorFlow model into a little script and ran a few images through it. So, since we are a little bit early, if anyone has any questions, I'll be very happy to answer them. Otherwise, I think we're calling it a early live coding for today. I'll be staying in the chat for a while after as well, so if you have any questions, just write them. But thanks very much, everyone, for joining. Always a pleasure to have this and have everyone here. Take care and have a great day, everyone. Thanks.